That means we have to show that if this is the circle with center O and AB and CD are two parallel chords, then the diameter, which is perpendicular to one of the two parallel chords, suppose it is perpendicular to AB, then we have to show that it is perpendicular to CD also. At the same time, it bisects CD. Okay. So here we have considered a circle with center O. So we have to write, let the circle has a center at O. And AB and CD are two parallel chords. So we get AB parallel to CD. We have also considered that the diameter, which is passing through the center of course, is perpendicular to one of the two parallel chords as per the given information. So let the diameter, suppose the diameter is xy, let the diameter xy is perpendicular to the chord AB. At P. Okay, that is angle OPB equals to 90 degree. This is equals to angle OPA. Okay, number 1. Required to show that the diameter, that is xy, perpendicularly bisects the other chord CD, where AB is parallel to CD. That is to be shown. So here clearly we get that XY is perpendicular on AB. So this angle is 90 degree and this one is also 90 degree. Now it is already given AB and CD are parallel. So sum of these two angles is equals to 180 degree as they are co-interior angles. So from this information we get this one is also 90 degree. So this diameter is perpendicular on CD also at the point Q. So as it is the diameter, so we get OY is the radius of the circle. So this radius part OY is perpendicular on CD. So here we get that the perpendicular OQ, here OY cuts CD at Q, we can see in the figure, the perpendicular OQ is on the chord CD and it touches CD at the point Q. So of course it will bisect CD. And hence we can conclude that CQ and QD are two equal parts. Right? So let's prove this. Proof. Here, angle OPB equals to 90 degree as OX, that is OP, is perpendicular to AB. Okay? From 1. From equation 1. Right? Here we have already declared it. OPB equals to 90 degree. Okay? Now, AB is parallel to CD and XY is the transversal, which cuts AB at P and CD at Q. Therefore, angle OPB plus angle OQD equals to 180 degree. As these are parallel, this is the transversal, so of course these two angles are co-interior angles, as angle OPB and angle OQD are co-interior angles. Co-interior angles, right? Therefore, OPB 90, so we can put 90 degree here, plus OQD equals to 180 degree. From here you can simply write from 1. Okay, therefore angle OQD is also equals to 90 degree. So OQ is perpendicular on CD. Hence it is proved. First part, it was the first part, perpendicular to the other chord, right? Now we know that if a perpendicular is drawn from the center to a chord which is not a diameter, I repeat, we know if a perpendicular, let me explain here, if a perpendicular is drawn on a chord which is not a diameter, then it will bisect the chord and vice versa. We know this is a very important property of circle, right? So here, using this property, we get that OQ is perpendicular on CD, as OQ is perpendicular on CD, so it will bisect the chord CD. As, what is the reason? The perpendicular drawn from the center to a non-diameter chord, to a chord which is not a diameter, will always bisect the chord. Will always bisect the chord. In one of my earlier videos, I have already explained this rule, and make sure it's this statement, the converse of this statement is also true. That if we can draw a line from the center to a chord, and if we see that that line segment is bisecting the chord, then of course that line segment will be perpendicular to the chord also. So converse statement is also true. Okay, in one of my previous videos I have already explained these two theorems. So hence the proof is done, that we have already shown that OQ is perpendicular on CD, at the same time it bisects CD at Q, so OQ is the perpendicular bisector. So let's write it. So OQ is the perpendicular bisector of CD, which bisects CD at Q. Hence the statement is proved. Hence the statement is proved. Hope the explanation is clear to all of you.